sketching the graph of this rational function using the steps written on the right, domain x-intercept, y-intercept, horizontal, vertical, asymptote, max and min, concavity, blah, blah, blah. All right, starting with the domain. So this is a rational function. Denominator cannot be equal to 0, right? But can the denominator equals to 0? X squared plus 1. You square a number, you add 1 to it, you will never get a 0, right? So you square a number, doesn't matter what number you pick, it must be 0 or above, or higher, or 0 or positive. You add 1 to it, that is guaranteed greater than 0. So x squared plus 1 never equals to 0, right? Never equals to 0. So the domain is all real numbers. The domain x, you can choose whatever you want, positive, negative, anything you like. And then y-intercept, I'm going to use different colors to divide this up. So y-intercept, you're going to let x equals to 0. So y equals to 3 times 0. 0 plus 1, so that is equals to 0. So 0, 0 is my y-intercept. And then x-intercept, you are going to let y equals to 0. So that doesn't look like y. So y equals to 0. So 0 equals to 3x squared divided by x squared plus 1. Top divided by bottom equals to 0. So the top must be equals to 0. And the answer is very clear. So x has to be equal to 0. So 0, 0 is both the x and the y intercept. So the intercept part is done. Moving on, we have the whole vertical asymptote. So since the domain is all real numbers, there is no vertical asymptote. So let's write this down. So for vertical asymptote, the domain of f is all real numbers. So for any number you like, so there is no vertical asymptote. How about horizontal asymptote? We do have a horizontal asymptote at y equals to 3. Let's get that. So for horizontal asymptote, we have to set the limit. So we have limit as x goes to positive infinity. You look all the way to the right. And then 3x squared divided by x squared plus 1. And this, since the highest degree in the denominator is 2, then you have to divide each term by x raised to the second power. Write this down. So divide each term by x raised to the second power. Okay, keep moving. X infinity, so this is a 3x squared divided by x squared over x squared divided by x squared plus 1 divided by x squared. And then the fraction, you clean up the exponents. Then you have 3 and then a 1 plus 1 divided by x squared. Once x goes to infinity, the fraction becomes 0. Then you have 3, 1 plus 0. So that is equals to 3. Then y equals to 3. This is my horizontal asymptote. So if you let x approaches to negative infinity, you will get the same thing. Y approaches to 3. So overall, y equals to 3 is my horizontal asymptote. And then moving on, we have, what do we have? We have first derivative, right? Okay, so let's save this spot for the graph. So let me do the first derivative on the left. So what's the first derivative? Okay, here, quotient rule. I'm going to leave the detail to you. I will just go straight to the derivative. Otherwise, this video will be like half hour long. So f prime of x, I will go straight to the answer. So that is equals to 6x divided by x squared plus 1 squared using quotient rule. And then you have to set that equals to 0. So you set that equals to 0. So that means 6x must be equal to 0, right? So we have 6x equals to 0. So therefore x equals to 0 is my critical number. Okay, you know what? I'm going to save myself a little bit more space because I want to squeeze more works on this page. So I'm going to move this using technology. This is so convenient. I'm going to move this and then move this right over here. And then I can move this up. Okay, good. So x equals to 0, and then I can do my test intervals, right? So draw a line. and then you have 0, so 2 intervals from negative infinity to 0, and then from 0 to positive infinity, right? And then this is, I'm going to pick x equals to -1 and x equals to 1, test that using the prime, so f prime of -1, f prime of 1, so that gives you a 1.5, this gives you a -1.5, so we have a less than 0 and a greater than 0, so this is a negative slope, this is a positive slope, so therefore x equals to 0 is a relative minimum. All right, so we have x equals to 0, so when x is equals to 0, y is equals to 0, so 0 comma 0 is my relative minimum and the x and y intercepts. So moving on to the double prime, the double prime has a lot of work, but it doesn't really help you to do the graph. So for the double prime, okay, I'm going to save these spots for the graph, so I will just do the double prime right over there. So let me do the double prime using purple. How's that? So double prime, so f double prime. Same thing, I will just give you the answer. That is -6 and then 3x squared minus 1 divided by x squared plus 1, and then raise that to the third power. And then to find the inflection point and study the concavity, you have to set that equals to 0. So you have the top equals to 0. And then 3x squared minus 1 equals to 0. So divide both sides by 6. 3x squared minus 1 equals to 0. Then you have x squared equals to 1/3. Be very careful right here. That's why I picked this problem. And then you have x equals to plus or minus square root 1/3. That is the same thing as plus or minus 1. Square root of 1 is 1 divided by square root of 3. And then you have to rationalize this. So if you take this, you multiply the top and bottom by root 3. This is called rationalize. Rationalize means you have to get rid of the square root in the denominator. You have a root 3, comma 3. This is approximately equals to plus or minus 0.58. Okay, and then we are going to do this. So we're going to draw a line. So for my convenience, I am going to use decimals. When I report my answer to an online homework system, I will use the fraction 58. So that is from negative infinity to negative 0.58, negative 0.58 to positive, and then from the positive to positive infinity. And then for the value, so this one I'm going to let x equals to 1, x equals to 0, and then this one let x equals to -2. And then you are analyzing concavity, so we will be using the double prime. So f double prime of -2, that gives me f double prime of -2, that gives me -0.53, and then f double prime of 0, that gives me 6, and then f double prime of 1, that gives me -1.5. So negative, so this is negative, positive, and negative. For concavity, negative means concave down, right? Positive means concave up, and negative means concave down. So this is concave down, concave up, and then concave down. So we have two inflection point, and then one right here, x equals to, okay, negative 0.58, and then this one is x equals to positive 0.58. So they are inflection. We have two inflection points, but it is very, very hard to see on a picture. I'm going to show you why in a minute. And then you have to find out the location of this inflection point. So you have to plug in. Do not plug in the approximation. Plug in the exact value. So root 3 over 3. So that gives you a 3 times x squared, right? So once you square, okay? There is a square right over here. Once you square that, the root 3 becomes a 3. This becomes a 9. And then the square of this, so 3 over 9 plus 1. So that gives you 3 over 4. And then f of negative root 3 over 3, that gives you 3 over 4 as well. Okay, so this is my inflection point. So we have root 3 over 3, comma 3 over 4. and then negative root 3 over 3, and then 3 over 4, they are my inflection point. To be exact, so we have 0.58 and then comma 0.75 and then negative 0.58 comma 0.75. So now we are ready to sketch the graph. Trust me, it is very hard to see, even though you do it on in a graphing calculator or any graphing software. This reflection point is very hard to see. But when you are doing this on a in-class written exam, you have to show the whole detail. Okay, we have space for the graphs, so let's get started. I am going to sketch the x-axis and the y-axis. And then this is y, this is x. Where is my horizontal asymptote? My horizontal asymptote is y equals to 3. So we have this. This is y equals to 3. So y equals to 3. That is my HA. And then we have x and y intercept and a relative minimum at here, right? Right over here. So this is a 0, 0. So this is a relative minimum and x and y intercept. And then what about the graph? Going down and then going up. And then since we have to accommodate the horizontal asymptote, it should look something like this. Like decreasing and then going up. It should look something like this because you have to go down and then go up. Okay, let me make this pretty. So we have to do this. So going down and then going up like that. And then where is the inflection point? The inflection point is like right over here. It's right over here. It's pretty hard to see, but it is there. So this one is 0.58. You cannot report approximation, right? So you have to report this root 3 over 3. This is part that most people hate. And then 3 over 4. This is a negative root 3 over 3. And then comma 3 over 4. So you have the same y coordinate because this is symmetric over the y-axis. Okay, so that's the graph of the function. We did all the works, like spend 15 minutes. If you do the derivative in detail, that will take you 20 minutes. So we have the 20 plus minutes of work to get this graph. So when you do this on in-class test or quiz, make sure the graph is nice and big and make sure you label everything, because I'm pretty sure you lose points if you don't do the labeling right. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video in any social media. For me, if you are new to the channel, please take 2 seconds to click the subscribe button down below. I appreciate your help really, really much. I will see you all in the next one. Signing out.